I am going to go make a recording of the first lecture on solving systems of equations. Well, let's look at this first one. We have 3x plus 2y equals 18 minus 2x plus y equals 2. There's a few ways we can solve this. We can use something called substitution, where substitution means you put one thing for something else. So if we take the second equation and the second equation that we have right here, we want to move things around. Notice it's only a y. That makes it easy. Let's put y on one side. To do that, we'll add 2x to both sides. The result will be y equals 2 plus 2x. And once we have that, we can take this y value and plug it into the y value of this first equation. That's where the 2 plus 2x comes from. You plug that in there. 2 times 2 is going to be 4. 2 times 2x is going to be positive 4x. And so now we've got 3x and a 4x make a 7x. And you can subtract 4 from both sides, and you'll end up with 7x equals 14. Divide both sides by 7, and then you have your x value. Once you have your x value, you can plug it into any one of these equations, or this might be the easier one. You plug it in wherever. And so 2 times 2 is going to be 4. Add that to 2. You end up with y equals 6. That's the substitution method. Elimination method is my preferred way to do it. For you, do the one that makes most sense to you. But let me show you how to do the elimination method. That's something that I wish I would have learned in algebra, but that's a long time ago. Elimination method, you want to make one of the equations where the x or the y variable is the same as the other one. And you can either add or subtract. For this one, let's do addition. And so we'll take the second equation right here, multiply everything by -2, -2, and -2. That's supposed to be -2x. End up making a 4x, 2 and y make a -2y, -2 and 2 make -4. And there we have our result. Let's take this number right here, drop it in right here. Then we can add that with this first equation. 4 and 3 is 7. Positive 2y, -2y, 0y. Now we've eliminated the y variable. 18 minus 4 is 14. And then we've got 7x equals 14. I divide both sides by 7. What you do to one side, you want to do together. And you end up with x equals 2. Just like we did with substitution, and you can plug it, you can substitute that into whichever equation you want to use, whatever makes most sense to you, and you'll get your result. That's how you do substitution elimination. Another way you can do it is you can graph it, just like we see right here. If you graph both functions, look at where they intersect, and that will be your solution. X equals 2, y equals 6. And it's always a good idea to verify that the equation works, because both of these, if you plug them into each of the two equations, you should get the result. And you do, which means that we did the math right. Okay, so there's that equation. Let's look at another equation. It gets a little more tricky when we do fractions because we have to do things a little bit more work. I'll do the substitution method. Substitution method is kind of handy for this one because we already have a y equals. So I took this y equals value and I plugged it right into where because y is 5x minus 7/2. You substitute in there, you work through the math, take the -3 multiplied by the 15, -3 multiplied by 7/2, and we get this result. And we've add up all the x values, we get -14. And then let's take this is divided by 2. we can multiply the numerator and the denominator by 10 on this side, numerator and denominator by 2 on that side. But really, we can see that 2 is a multiple of 10. So that would make sense just to make, we can make them like a lot easier just by taking this thing right here, multiplying the top and the bottom by 5. You multiply something, the top and the bottom, by the same number, you essentially multiply it by 1. Anytime you multiply something by 1, it is itself. So that we can do that. That gives us negative 14 minus 105 over 10 equals 21 over 10. If we subtract 105 from both sides, 105 divided by 10, we end up with negative 14 over 84 divided by 10. And if we take divide that by negative 14, divide that by negative 14, we get x equals 6 over 10, which comes down to x equals 3/5. And there's our answer for x. We can take that number, plug it into this equation. You can do the equation that seems to make most sense, easier for it to work through. We plug it in right here. We get y equals 15/5 minus 7/2. Let's take this, multiply it by 2. Let's take that, multiply it by 5. We end up with that thing. 30 divided by 10 minus 35 divided by 10. 30 minus 35 is negative 5. And negative 5/2, we divide both sides by negative 5, you get y equals negative 1/2. That's using the substitution method. In addition to the instead of the substitution method, maybe we could have just graphed it out. And we'll have our solution. That's a little bit tricky because of fractions. And so you have to be able to interpret that. But it's always handy if you take these numbers, plug them back in to the original equations, and you should get a statement that's true. If you did the math right, you will. There's problem 2. Problem 3, we have this system of linear equations. It's not possible. Using the substitution method, y equals minus 2x plus 5, we'll plug that in. This thing, we'll plug it into the y, 4x. We take 2 minus 4x minus 4x, which is what you get from here, plus 10, 2 times 5, which is 10. You end up with 10 equals negative 2, and that's not true. So we call this an inconsistent system. These two equations are parallel. Well, that's a really bad line. But no matter whatever you go in your domain is your x value. If you go back to infinity on either side, with a system of linear equations, they will never touch. There is no solution to it. So that's why we call it an inconsistent system. That is where am I? Okay, let's look at this next one. 4x plus 2y equals 10. Y equals negative 2x plus 5. If we do the substitution again, we end up with, if we take this y equals that thing, plug in the y value, we end up with 10 equals 10. There's no variables in there. And really what's happening here, we have the same line. It's a completely dependent system. For any value of x, anywhere in the domain will have the exact same value of range on the y. It's all the same thing. And so that's what we call a dependent system. Problem 4. Let's look at problem number 5. This is a quadratic equation. Y equals x squared plus 5x plus 3. Then we have the other equation. You could do substitution. Substitution would work because you have, well, if you solve it for x and then plug that into y, either way, however you solve it, that's one way to do it. But they're both y, and so it might make more sense to go ahead and just set them equal to each other. So that's what I did here. These are equations equal to each other, and then that's a few less steps to do the substitution method. But once we have that, let's these are actually equal to 0. I wanted to make that a little more correct. So I subtracted. I took this 2x and I pulled it over here. I took this 3, I pulled it over here, and this is equal to 0. The result, so x squared plus 3x equals 0. And we can use the FOIL method. And to do the FOIL method, you want the numbers where these two multiplied by each other end up with that. And the other thing you want to think about is you want this number times that plus that times that needs to equal that. And to do that, we end up with x plus 3 times x plus 0. So these are actually equal to 0. And how do you get something equal to 0? You multiply by 0. And so the only way you can have this be a 0 is if, so you can set these as x plus 3 equals 0 and x plus 0 equals 0. So you end up with here, the only way you can have this equal 0 is if x equals -3. With this second equation, the only way you'll have x plus 0 equals 0 is if x equals 0. And that gives us our x values that we have right here. You can take those x values, plug them into either one of these two equations. It doesn't matter which one. The linear one might be a little bit faster. You plug that in there, you'll end up with your y value. So if we take -3 times 2 is going to be -6. -6 plus 3 is -3. That gives us the first pair of solutions. The second one, you plug in 0. Oh, that makes it 0. So y equals 3. And you could graph these out. And let's see. I think the low point on here is -b over 2a. So this is a, b, c. So a is 1. And you can do that to get the low point right here. Where these two equations intersect is going to be right here at -3, -3. And the other one is going to be at 0, 3, right here. And there is, so that's our quadratic equation. Look at problem number 6. Here's a word problem. To do this, we want to solve create two functions. You're renting car. There's two ways to rent a car, two rental companies. One charges $15 a day plus 10 cents a mile. Zippy's is $18 a day and 8 cents a mile. So if we want to make that for an equation, we can say y equals 15 plus 10x. So $15 plus 10 cents a mile, and that gives us our total cost. We can do the same thing for Zippy. $18 a day plus 8 cents a mile. And there's a few ways we can solve this. One way, let's do elimination. Oh, actually, we could set this one, we set them equal to each other. Elimination would have been faster, but that's not what we did here. They set them equal to each other. But it'll work. And so you subtract 15 from both sides, subtract 8 cents from both sides, and we end up with 0.02x equals 3. Divide both sides by that, and you end up with x equals 150 miles. So what that means is at 150 miles, both of them cost the same. If on the other hand, and if we drive under 150 miles, you should pick ACE. The red line shows the cost of ACE. The difference between the two is how much more you're going to have to end up paying. That's your opportunity cost for not having picked the other one. On the other hand, if you're going to drive more than 150 miles, this value right here, you should pick Zippy. Zippy's the blue line, and that one's less than red. And the difference will be the amount of the space between the two. Okay, there's our car problem. This next one with beads. Amber sells and makes beads. Green beads cost 95 cents an ounce. Blue cost 60 cents an ounce. And she wants to make a mix of 16 ounces worth 75 cents an ounce. So if we The first equation is the blue plus green equals 16. That's what she's trying to go for. And then the next one is the cost, 60 cents times the blue plus 95 cents times the green equals then the cost of 16 times 75, which is 12. And if we do substitution or elimination, or we can graph it out, we'll end up with blue beads being about 9.1 ounces, green bead being 6.9 ounces. You work through the math on that one. The next one we have the Jazz are playing. They made 80 points against the Lakers, but they made 37 baskets. And baskets, for the scenario, they must have played a clean game. There are no foul shots, or not the foul shots were made. So there's only 2 points and 3-point shots in this scenario. So how many 2-point shots did the Jazz make? First of all, we want to set up the system of equations. We have the 2-point shots, or where the X is for the 2-point shots. How many of those did they make? And the 3-point shots, all of those end up with 80 points. So the number of 2-point shots times 2 plus the number of 3-point shots times 3 will equal 80 points. And there are 37 baskets, or 37 shots were made. So all the 2-point shots and all the 3-point shots make 37 baskets. Those are our two equations. And we can do, with this one, if we take x plus y equals 37, then if you subtract y from both sides, you end up with x equals 37 minus y. And if you take that value and plug it, or we could, what do we do here? X equals 37 minus y. And we plug it into this equation right here. We end up with 2 times 37, which is 74, 2 times negative y, which is negative 2y, plus 3y equals 80. We work through the math. Y equals 60, or y equals 6. And if we plug in y equals 6 right here, subtract 6 from both sides, we have x equals 31. So we have 31 2-pointers and 6 3-pointers. Or we could have worked through that. This one relates to, I rented a U-Haul. After we bought our house, we had to take stuff out of a storage unit and bring it to the house that we purchased. And the U-Haul had 2 different rates. They had a distant rate and a local rate. The distant rate was a pretty big U-Haul. It was $119 plus 40 cents a mile, or the local rate of $40 plus $1 a mile, or $39.99 plus 99 cents a mile. And to help me decide which one of these was more cost effective, I did a little bit of math. First of all, I computed what's a break-even point for the miles. Just like the Zippy and Ace rental, you can figure out where the number of miles is the same. And then I used some software to figure out how many miles it was from the U-Haul place to the storage unit, and then to the house, and to a gas station to top it off, and then back to the car rental. And knowing where the break-even point would be really helpful to help us figure out the most cost-effective approach. And if we graph it out, well, we can either work through the substitution effect or the elimination effect. I mean, really, these are both y equals 119 plus 0.4 times x, or miles, whatever variable you want to use. Set them equal to each other, and then work through the problem. You end up with about 133.9 miles. If you graph it out, it looks like this. So that means if I'm going to be going some distance less than 133.9 miles, I want to go for the local rate. If it was more than that, certainly want to go with the distance rate. And then let's look at the very last problem. There's 3 boxes of oranges, 14 boxes, 3 small boxes and 14 large boxes ended up costing 203. 11 small boxes, 11 large boxes equals 220. Let's find the cost for each of these. And if we, there's a whole bunch of ways to do this. You take the first equation and you multiply it by 11 and take the everything in the first equation, multiply it by 11. The second equation, take everything in there, multiply it by 3. Those, you're basically scaling these. You end up with this thing right here. And then we can start subtracting. So if you have 2,233 minus 660, you end up with 1,573. Take 33 small boxes minus 33, end up with 0. That's why there's nothing there. 154 minus 33 is 121. And then now that we have that, you can take, let me clear that up a little bit. Divide both sides by 121. If I write that right. And then that means we have 13 bucks for a large box. And we can take that 13L and plug it into either one of these. And then we'll solve for the small. And we end up with $7 for the small box. And great. I hope this little video helped. And there we go.